Welcome back to your Algebra 1 Semester 1 final exam review. Problem 54 for this year looks at the piecewise function that's here. And what we're going to do is after we graph the piecewise function, we're going to try to figure out which of these absolute value equations, or regular lines, matches with the piecewise function. And that's a really important connection, being able to relate absolute value back to piecewise. It's pretty important, especially once we get to solving those absolute value equations. So let's graph the piecewise first. I'm going to color coordinate this. I'm going to graph one equation, x minus 3 in blue, and the other one in red. Now, there is a second part to a piecewise equation, and I want to kind of break that down for you on the side really quickly before I graph. A piecewise equation has multiple different equations, right? And we only do a piece of each one. So this equation has two equations built in, but we're only going to do a piece of the blue one, a piece of the red one. The way piecewise equations are given to you is they're given, here's an equation, and then comma, here's when to use the equation. So for example, our piecewise equation f of x says, here's this equation, but only use it for x's that are greater than or equal to 0. So let's take a look. I'm just going to graph 1x minus 3. You should be comfortable with your slope-intercept form, but I'll remind you of that up top. We know that the number that's adding or subtracting is our y-intercept, and the number that's multiplying is our slope. Okay? So our y-intercept is negative 3 then. I'm going to start at negative 1, 2, 3, that's right here. And then our slope is that invisible 1 that was hiding in front, so I'll treat it as up 1 over 1. And I'm just putting a couple dots on here for now, and we look something like that, give or take. Okay. However, we only want to use this blue equation for x's that are greater than or equal to 0. And I always suggest that my students go ahead and do a little dashed line right where the two equations split apart. And they'll usually split apart at the same spot. So they're splitting apart, and I like to call it a wall, at 0. So right on the wall, right where I put the wall, that's where the x is 0. Any point on here is 0 comma something. To the left side of the wall, well, those are x's, and I'm dashing on the x-axis right now. Those are x's that are smaller than 0 because they're the negative, so those are x's less than 0. And then the right side of the wall, those are x's that are greater than 0. So looking at this blue equation then, it says only use the equation 1x minus 3 for x's that are greater than or equal to 0. So greater than 0, those are x's on the right side of the wall, we want that side. Less than 0, well, we don't want to use it there. So we're actually going to erase our equation, and we're only going to use this side. A piece of the equation. Piecewise function is just using a piece of an equation. Right at the wall is when x is 0, and this does say for 1x minus 3, x equals 0. It says use an x that's equal to 0. So we're going to keep a dot, a closed dot, right on that wall. Alright, now let's go ahead and take a look at our second equation. Our second equation says that we want to do the equation negative x minus 3. Negative x minus 3 starts at negative 3 and then goes down 1 over 1 because of that negative slope. And it's going to look something like that. Okay. So now I have the red equation, but I don't want the whole thing. The wall tells me I only want to keep the red equation for x's that are less than 0. Less than 0 is this side of the wall, so I'm going to erase the right side and then go ahead and connect. Now normally we wouldn't be equal to 0, so normally for that red equation we put an open circle right on the wall, but because blue already made a closed circle there, it's really just going to be a point right at the wall. So we have this equation looking good so far. Now we can answer the question. The question says, which of the following functions is equivalent to the piecewise equation that I just graphed? Now, C and D are both lines. There's no absolute value there. This is not a line. A line is just straight, right? This one is two lines put together. C and D have to be out. It's either A or B. So if you look at A, that says the absolute value of x, but shifted 3 units down. And then B says the absolute value of x shifted 3 units down, but then with a negative slope. So both of them are going to start in the same spot. They're both going to start at 0, negative 3, which they do, right? This is 0, negative 3 right here. However, B has a negative slope, and if this piecewise function started at 0, negative 3 with a negative slope, it would look like that. And that's not what our graph looks like. So that means that B is out and we must be A. Positive slope starts there, and then it goes up 1 over 1 in each direction and makes the exact same shape.